myself Somasree Samanta hosting this webinar on the topic Importance of Environmental Awareness among Gen Z and beyond on behalf of Community Outreach Initiative by the students of M.Sc Environmental Science Department, University of Calcutta. Environmental awareness is itself an umbrella topic, and for that reason, we have arranged a series of webinars based on different angles. And today is webinar series number 7. And before that, we have arranged 6 more such events, and in forthcoming days also, we will be arranging more such webinar so that we can spread awareness among all via community outreach activities. Today is 11th of July and is also celebrated as World Population Day by Resolution 45 by 216 of December 1990. The UN General Assembly decided to continue observing World Population Day to enhance awareness of population issues, including the relation to the environment and development. The current world population is almost 7.9 billion as of July 2021, according to most recent United Nations estimated elaborated by Worldometer. And many scientists think that Earth has maximum carrying capacity of 9 to 10 billion. So it's also a huge matter of concern for all of us. In order to understand the innate value of education and how education goes beyond class, I have invited Mrs. Jayanti Sarkar, ex-principal of Pranavananda Vidya Mandir, Durgapur, who was my principal also during my school days. Now it's over to you, ma'am.
Thank you so much, Sri, for inviting me in this webinar series. I convey my heartiest greetings to all, greetings to my co-speakers, and greetings to everyone present here. I've been given the topic to speak on importance of environment awareness program to school education. As I have been attached to the school for many years, and congratulations on environment awareness activity program. So I like to highlight few things on that importance of environment awareness. Environment, as we all know, environment and climate change issues becoming a huge concern for the entire world. Environmental awareness is about being aware of our natural surroundings and how our actions affect our environment and nature, and also how our environment plays a significant role in our existence. Nature creates and contributes in balancing our environment, providing us all a healthy life, making our planet a planet of livable, lovable for a peaceful coexistence of all its stakeholders, the human, animals, trees, plants, flora, fauna, and earth. It's amazing to see how nature provided us with every necessary thing for life. Abundance of air, lush green vegetation, crystal water bodies, and vast forest land. Nature satisfies all our needs, not our needs. As civilization progressed and prospered, our nature and environment declined. 21st century is experiencing more and more environmental challenges due to climate change. Global warming, global, global climate fluctuations, unpredictable rain and monsoon, causing floods, flash floods, um, cloudbursts, etc. Increasingly hot summer, causing drought and frequent occurrence of cyclones and typhoons, uh, causing disaster. Melting of ice caps and sea level rising, are great concern and great environmental hazards and challenges. But because of our mindset, we fail to connect the link between all these calamities, that is, environmental resilience. It is extremely important to be environmentally aware, to preserve, to protect, and to promote the sustainability of our planet Earth. And here it is important to make our present generation environmentally aware from the very early stage of their school. The main aim and objective of environmental awareness through school education is to develop an understanding among the students of what environment is and how human behavior impacts our environment, preserving ecology and how preserving ecological balance is crucial in our life. It is also to develop how environment friendly and to be there and how not to hurt it or damage it, our environment. It is almost imperative to develop a set of responsible, sensible, and environmentally sensitive future citizens who will carry the banner of environmental awareness forward for protecting it in a sustainable way for the present generation as well as for posterity. This is possible only through school education, which is the right place when they are in their most formative years, most flexible and moldable, adaptable, and capable of receiving any lessons imparted to them. The stakeholders of education have a significant role to play here. They need to include and integrate the subject in the school curriculum, which will give ample scope and opportunity for the students to learn the subject effectively and to understand its importance. Many councils and boards, including our ISIS Council, had a wise thought and introduced the environmental education in the school curriculum as compulsory subject up to secondary level to develop awareness, concern, and knowledge on our environment. However, after a few years, this it was only withdrawn, citing that it was an additional burden for the already burdened students. We may only hope for the good sense to prevail to reconsidering its importance and include it again in the school curriculum. Different selection committees, its importance is noted also as different selection committees, boards, and commissions like school service commissions have added it in the list of subjects to be tested. Personally, my long association with the school Pranavananda Vidya Mandir at Durgapur as vice principal and as principal, I feel privileged to get some scope and opportunity of involving myself and the students with various school activities on environmental awareness to promote among them the awareness on environment. Our sincere and dedicated teachers extended their cooperation in devising environmental awareness and coordinated lesson plan practical activities oriented that make the subject more applicable, acceptable, and appreciable and interesting to the young minds. Eventually, they will grow up to take the challenges of recovering our environment and act to help repair it. Different activities in the school level various activities that are taken at the school level, like to cite some of the examples. To begin with, very basic activities like planting of saplings in the school campus and taking care of each plant by each individual. It is the simplest way to connect with nature. Students may take up this up to their neighborhood, to their community park, even they can plant trees beside vacant roadsides. Posters and slogan writing, banner and placards making activities are important for the awareness with thoughtful messages written on those. Theme based collages and paintings are also a part of awareness program on global warming, water preservation, carbon footprints, industrial pollutions, etc. Meaningful wall painting and wall writing are suitable places like school library, school auditoriums, and school hall, etc. Activities of live performance like skits, plays, short drama, tableau are organized depicting the impact of pollution on human life, animal lives, and birds and vegetation. Trees absorb carbon, protect trees, nurture nature. Creative writings of essays and poems with original thoughts and ideas, and participation in debate and elocution, quiz, extempore, etc., are a part of different activities. Activities of Eco Club are formed on group activities on Eco Clubs are formed to involve more and more students, like planting of medicinal plants and useful herbs in a specified area in the school campus. Also, processing of organic manure, compost, and worm farming. Awareness on giving, giving up of single-use plastics, making the school plastic-free zone. Simultaneously, usage of alternate, recycled, environment-friendly materials like paper, jute, cloth, and even earthen pots. Students are encouraged to discard plastic bottles and they may bring metal water bottles. Activities in participation in road rally and procession, environment walk through the streets, holding placards and banners with upholding the message on awareness on preserve and conserve our environment. Cleaning of school campus, classrooms, corridors, and also these activities can be extended to their nearby marketplace, public places, cleaning of rotary near the school areas, etc. In Swachh Bharat Abhiyan at Durgapur railway station, students participate in cleaning the platforms, placing waste bins, and also handing over flyers to the alighting passengers and spread awareness among them. Activities at secondary, middle school, and secondary level are making live projects and models on waste recycling, rainwater harvesting, solar usage, solar energy usage, and windmill turbines. On Saraswati Puja Days celebrations, Saraswati Puja celebration day, art exhibition and live models on science and environment projects are displayed, all prepared by students. Another activity to reduce carbon footprints, uh, encourage to walk on foot or walking on foot and using bicycles. These are some of the ways to reduce carbon footprints, and while commuting, avoiding cars and other carbon emitting vehicles, common public transport like train and bus may be encouraged to use. News bulletin, school news bulletin on a fixed day in every week, reading out environmental news in the school assembly, highlighting on the happenings in our country, our and around the world on different meets and summits, plans and policies and different movements that are taking place from time to time. At the end of that environment news, the thought for the day on environment is read out by the student. Observing important days like Earth Day, World Environment Day, World uh, Forestry Day are all encouraged. But these awareness activities are a continuous process throughout the year. It's a year long process. It's not a single day's celebration or observation. The small but dedicated steps make a huge impact, and our young generation be committed to carry the message with them throughout their life, raising global consciousness. Activities engaging students in spreading awareness among neighbors, communities, and at home also, involving their parents, grandparents, family members, and even juniors, brothers, and sisters, of importance of planting trees. They may plant a tree, take up a single sapling and plant and take care, protect it, touch it, fill it, and watch its gradual development. In this way, connect with nature closely, observe nature closely. Even they can offer saplings to friends on different occasions or exchange saplings on different occasions as a gift on some occasions. Make paper and jute or cloth bags and gift others to use it instead of plastic bags. Awareness on judicious use of our resources. Discourage to waste water by the mates, even your moms at home. Focusing on water cycle, how our everyday actions can help achieve water preservation. Switching off fans, lights, ACs when they are not in use. Also, students may be encouraged to sit under the trees and teachers to take classes under trees or open places to become to allow them to come in close contact with nature, to become aware of their social and community responsibility towards environment. They can take part in organizing protest against cutting and felling of trees, filling up of water bodies, wetlands, just to accommodate an exploding population. Citing example of Greta Thunberg, a teenage Swedish student activist who urged Swedish parliament to act on climate change. Students may students voice their opinions on awareness at school through school magazine. They may write a column on newspaper and media, giving views on current environment concerns of a region or a particular area, like a plan which is coming up of developing new Nicobar Islands as a big port, and also plan for developing Lakshadweep as tourism hub. These are all against environment and ecological balance. So that will impact local environment and ecological balance, and also displacement of original habitats of the region. So to stop climate change apocalypse, students take part and come forward with different activities, procession, road march, etc. They can voice their views, writing on papers and media. Lastly, I like to conclude, even dinosaurs thought they had time. The same thing must not happen to humans. In the book, The Sixth Extinction, the writer Elizabeth Colbert warned of devastating sequel. It is high time to act now and help protect our environment to the best of our ability. So all these are school children oriented activities as schools may take up, be aware, make the children aware, and make our environment a livable, lovable place. Thank you all. Thank you for patience hearing. Thank you, Somasree.
Thank you, ma'am, for sharing your valuable words and experience. Now, I will move on to our interactive session. Participants, you may ask any question directly to ma'am.
গুড ইভিনিং ম্যাম। ম্যাম আমি বলছি যে কোনো রিজন স্পেসিফিক কি এনভায়রনমেন্টাল এডুকেশন দেওয়া যাবে? মানে ধরুন দুর্গাপুরে এয়ার পলিউশনের একটা সমস্যা আছে, আবার সুন্দরবনে আপনার মানে ওয়াটার সিঙ্কিং বা সি লেভেল রাইজের একটা সমস্যা ইন ফিউচার হতে পারে। তো মানে যে রিজনে যে স্কুলস গুলো আছে, তো সেখানে কি মানে যার যার যেখানে সমস্যা সেইভাবে কি কোনো এডুকেশনের সিস্টেমের কোনো মানে ইমপ্লিমেন্টেশন করা যাবে ইন স্কুলস?
Because it is, yes, right point, because it is activities oriented, so regional schools will take their activities accordingly. Like Sundarbans, they have their mangroves and all this seawater and swampy lands. These are their own problems. So there, the teachers must take care of those, and students be aware of those particular problems in the particular situation and area. Whereas in Durgapur, it is so different problems. Here it is mainly industrial pollution, and that is major concern. So definitely Durgapur's problem and Sundarban's problem will not be similar, and not it will be dealt with similarly. So there will be certainly different activities to develop awareness.
থ্যাংক ইউ ম্যাম।
Thank you. Thank you.
Anyone else? Do you want to share anything with us?
আমি একটুখানি বলবো।
হ্যাঁ স্যার, নিশ্চয়ই।
আমি ধন্যবাদ জানাই ম্যাডামকে এত সুন্দরভাবে গুছিয়ে বলার জন্য, এবং আপনি যেভাবে গুছিয়ে সমস্ত বিষয়গুলো কেমনভাবে ছুঁয়ে গেছেন, আমার খুব ভালো লাগলো। সেটা গ্রেটা থুনবার্গ থেকে শুরু করে আমাদের কি প্র্যাকটিস করা উচিত এবং আমি বলবো যে এনভায়রনমেন্ট অ্যাওয়ারনেস আমরা যে মোটিভেশন নিয়ে এই প্রোগ্রামটার স্টুডেন্টরা করছে, আমার মনে হয় সমস্ত জায়গাটা ম্যাডাম ছুঁয়ে গেছেন। এবং এই জায়গাগুলো আমরা চাই যে সবার সবার মধ্যে এই ইন্সপিরেশনটা যাক, এবং আরো বেশি করে মানুষ প্রো এনভায়রনমেন্ট চিন্তা ভাবনা করতে শুরু করুক। তাহলেই আমরা একটা নতুন পৃথিবী পাবো। এবং ম্যাডামকে আমি আবারও ধন্যবাদ জানাচ্ছি যে এরকম ভাবে গুছিয়ে বলেছেন, এবং আমাদের ছাত্রী তার ডাকে সাড়া দিয়ে রেসপন্স করে এত সুন্দরভাবে আমাদের বলেছেন। অনেক ধন্যবাদ ম্যাডাম। এবং
Thank
সোমাশ্রী, তোমাকেও ধন্যবাদ জানাচ্ছি এরকম একটা সুন্দর প্রোগ্রাম অ্যারেঞ্জ করার জন্য।
Thank you, sir. Thank you so much.
হ্যাঁ, কন্টিনিউ করো, আর যদি কারোর
And
প্রশ্ন থাকে কিছু। ও আরেকটা কথা, ম্যাডামের কাছে একটা লিংক যাবে। ম্যাডাম, আপনি একটুখানি ফিডব্যাক একটুখানি দেবেন, আপনার কেমন লাগলো আমাদের, সেটা আমাদের বিভাগের কাছে রক্ষিত থাকবে, আপনার আপনার মতামতটা আমরা ভবিষ্যতে আরো কি করতে পারি। আমরা একটা মেল পাঠাবো আপনার কাছে ম্যাডাম, এবং আমাদের পরবর্তী স্পিকার ডক্টর গৌরব আছেন, তাদের কাছেও আমার একটা মেল পাঠাবো আমরা। আমি হয়তো পুরো প্রোগ্রামটা থাকতে পারছি না, কিন্তু আমার আই উইশ অল দ্য বেস্ট ফর ইউ। থ্যাংক ইউ।
Thank you. Anyone else to ask any questions? No?
Good evening, ma'am.
Yes, good evening.
Good evening, all. Ma'am said very well, really, that what happens in the school, the activities which really happens in the school, all these things, ma'am said very well, and what to be happen, what the teachers must do in the school, that also ma'am said in a very brief way. So, I would like to say that as one of you are saying about the environmental pollution in the Durgapur, so how we can control that one as a student, he is saying. So I say that we the teachers, what we can do in the school stage up to class 10, the school stage, we would able to show the seed of keeping the environment clean, protecting the environment clean. So that part of work we are doing. Now, today they are the children, so tomorrow they used to become like you, just like the Somasree. So then the responsibility is on your shoulders. So you should able to go to these factories are there. In these factories, definitely they are cleaning system is there, scrubbers are there, ESPs are there, but if they are not using, so that's why
Yes,
this
that is the
pollution is.
problem. The industries are not using properly those
Yes,
instruments
ESPs
and
and
that's
the
the
scrubbers, they are not using. So what the pollution control board is doing? So in the pollution control board, you people are there. So I request that everyone, so everyone must think that yes, we have to protect the environment. So the industrialist must also think. So who is working there, he or she must also think. And seed of thinking, that seed of thinking as a teachers, we are developing in the children right now. So that part
yes.
of work we are doing, and with the help of Jayanti Sarkar ma'am, I would able to do as much as possible in this regard. And here also ma'am said nicely some important points. I would like to do those things also among my students, ma'am. Thank you, ma'am.
Thank you. Yes, it is very important. That is why the importance of developing this awareness through school education. That is the basic time for the students to learn. And the students are capable of receiving whatever is imparted to them. It's not their burden at all. Senior people are education, many educationists think that it's a burden to them. And for that, the environmental paper was withdrawn compulsory. But I don't think, rather, you also think you are the teachers and you best know that how capable they can expand their capability as you put on,
Yes.
and they will expand and receive everything. So that is the right time, right place to make them aware so that they can carry this awareness throughout their life. When they will grow as adult citizen, they will engage themselves in their service life. Even then, they should they should not forget what they have learned in the school level, and wherever they get opportunity to organize any environmental awareness program or even making human change, and encouraging others to making human change whenever they find any environmental hazards are going to take place.
নমস্কার ম্যাডাম। বলছি ম্যাডাম
Ma'am, Kaushik sir
আমরা
is with us.
Yes.
হ্যালো
Ma'am, Kaushik sir is also with us.
কৌশিক স্যার।
Oh,
হ্যাঁ স্যার, আপনি বলুন।
oh, it's Kaushik. Okay. Yes.
ম্যাম বলছি যে আমরা এই এনভায়রনমেন্ট সায়েন্সের ব্যাপারটা মানে পরিবেশবিদ্যা যা কিছুই আছে না কেন, আমরা এটা শুধু মানে বাচ্চাদেরকে হয়তো আমরা সেইভাবে শিক্ষিত করছি হয়তো বা সেইভাবে শিক্ষা দেওয়াও হচ্ছে, কিন্তু ভবিষ্যতে যা দেখা যাচ্ছে বা কিছুদিন পরেও হয়তো যেটা দেখছি সচেতনতা মানে এটা কিন্তু কন্টিনিউ কিন্তু তাদের মধ্যে কিন্তু থাকছে না। একটা ব্যাপার যেটা হচ্ছে যে তারা না শুধুমাত্র নাম্বারের পিছনেই কিন্তু দৌড়চ্ছে। এবং আরেকটা ব্যাপার হচ্ছে যে এই যে মানে পুঁথিগত শিক্ষা ব্যাপারটা আর কি, এটা আমরা ব্যবহারিক জীবনে কিভাবে প্রয়োগ করতে পারবো, এটা সবসময় আমরা কি করে ধরে রাখবো। এর জন্য এটা যে আমাদের পরিবেশ, এটা যে আমাদের পৃথিবী, এই ব্যাপারটা তাদের মধ্যে কিভাবে আনা যায়। শুধুমাত্র নাম্বারের পিছনে ছুটতে গিয়ে এরা জাস্ট যখন আমরা এই ব্যাপারগুলো দেখেছি হয়তো এর মধ্যে আমি কত বেশি নাম্বার পেলাম আর কি, কিন্তু সেই ব্যাপারটা কিভাবে আমরা ছাত্রছাত্রীদের মধ্যে জাগরিত করতে পারবো।
The basic problem is that in our education system that students learn after learn. Their other parts are not neglected, and or their parents, guardians, even teachers, everyone makes that chain to run after their marks and results and all these things. And even some parents discourage. I like to encourage the parents through students' activities. Students can encourage the parents at their home, even grandparents and others at their home, citing many activities and their um, works and awareness, communicate them. But some parents are not ready to listen to this, thinking that these are all wastage of time. Rather, they should spend more time or contemplate more time to their studies and to their curricular activities only, not that extra things. That is what major problem that is the student is facing. And then when they cross the school level, they go for competitive exams and this that. And when they enter colleges, unless they carry that, or the school, college also encourages them to involve them in some activities, awareness activities, uh, that everything will be lost. All that teachings and activities and everything that is imparted to them will be lost. So it is the chain of
আচ্ছা ম্যাডাম আমাদের যে হ্যাঁ
junior
বলুন।
teachers, I mean some teachers, students, parents, and to the higher level also. The industrialists, the companies where they work, it's everyone's responsibility. Only school, basic level school cannot do everything. It is our responsibility that from the very beginning that we should develop this attitude towards environment, love for the environment, what environment is, why we need to protect the environment, what is its importance to our life, what may happen in future if we do not take the responsibility of protecting our nature and environment. These things, unless they are imbibed from the very beginning, they will forget everything for the future. And moreover, it is a total system. Everyone has to be aware, not only school or college, in their companies, in their industries, everywhere. Yes. Anything?
Thank you, ma'am. Thank you, Ganga ma'am, and Kaushik sir as well.
Good evening, ma'am.
Thank you. Kaushik. Thank you, Banga
Good,
Devi.
good evening, ma'am.
Good evening.
Uh, I'm Shampa Chatterjee speaking.
Okay.
Ma'am. We find that nowadays not only children, it is parents who
Yes.
actually teach the children to be away from the environment, because parents are only concerned with their nuclear family, the father, mother, and the child. So in this case, and now today we are in online situation. So how can we handle this situation and teach them, especially basically we are English teachers. I think you can also feel this as English teachers. How can we train them to be to do some work for the environment, or think about it, help the others to work for it? How can we do it?
Listen, Shampa, being as an English teacher, it is advantage to you more because there are numbers of poems and stories and short stories and essays on environment. Wordsworth, nature poets, Shelley, kids, and they have so many. They are included in their syllabus also. So why teaching such a poem? As an English teacher, I am telling you. Immediately you can connect this to environment and nature poets and nature related matters. However, it is definitely difficult time we are passing through. Moreover, this pandemic situation is going on, and their students are not in directly contact with teachers. Uh, Teachers only impart through uh, um, media and online classes. Here, teachers can communicate the students through their online classes what is the importance of environment and what you need to do, and parents can take up the matter at home to guide them on their projects and whatever is communicate to them by the teachers. So anyway, I feel that as an English teacher, you can communicate with the students whenever you find some opportunity, a little opportunity, little scope to communicate them with nature. And there are great poets of environment and nature, you know better. And whenever while teaching, you immediately can communicate that this is the thing, nature is this, nature is that. It's like you can cite the poem and sounding cataracts haunted me like a fawn that Wordsworth Clinton Abbey. How nice this poem is. How you can communicate with small children with this awareness on nature.
Okay, madam. Thank you, madam.
Thank you,
Okay.
ma'am. Thank you to all my school teachers for such interactive session, such rich interactive session. Now we will move on to our next speaker, Dr. Gaurav Dhar Bhowmik. He will speak on the topic carbon capture and sequestration technologies and their impact on environmental ecology. He did his PhD from Kharagpur IIT and presently pursuing postdoctoral studies at Ben Gurion University of the Navy. His main working areas are ion exchange membrane, microbial fuel cell, ORR catalyst, carbon capture, and wastewater treatment. Now I would request my next speaker to begin with his presentation.
Hello, am I audible, Somasree?
Yeah, audible.
Yeah, thank you so much, Somasree, for this opportunity to speak on this forum, and thank you so much, our earlier speaker, Mrs. Jayanti Sarkar. It's really a thought-provoking lecture, and it's really a lot of things to learn. And definitely, we need these kind of activities to be taught from the very beginning of our childhood. But it would be better to start with the school, as she has mentioned, obviously, and in later stage also we should continue it. Thank you so much, Mrs. Sharma. So in my talk, I will just share you. I'll just discuss about a specific topic, not in general. Can you see my screen?
Yes, it is visible.
Yeah, okay, thank you so much. So I'll be more concerned with a very specific topic in this lecture. I'll talk about I'll more discuss about the carbon capture technologies and different carbon storage technologies that is available on the market, and why it is necessary and why we need to go through this discussions at this moment of time, and why it is very much important at this moment to discuss about this carbon capture and storage technologies and how it will impact on our environmental ecology and so on and so forth. So first of all, why to go for this carbon dioxide capture and storage technology, and what it means by definition? As per the Intergovernmental Panel of Climate Change, Panel on Climate Change (IPCC) by WM and WNEP, it says that carbon dioxide capture and storage is a process consisting of the separation of carbon dioxide from industrial and energy-related sources and transport it to the storage location and long-term isolation from the atmosphere. So it's very bookish, right? Yeah. So it says pretty much everything that is needed to be learned. So why we need to go for it? Why we need to go for the CCS technologies at this moment? It's only one word can definitely explains it. Is the global warming, and you know why? See the endless amount of reports, endless amount of newspaper cuttings I can show, like what's going on all around, right from the beginning of like almost 30 years back, more than 30 to 35 years back, scientists have already warned all our policymakers about the possibility of global warming, and it has already begun at that time. And now we end up having in this period of time when we are actually experiencing that particular global warming phenomena, and not by it's giving us very hard time. Believe me, all around the world, right from the record temperature in Antarctica of 18 degrees Celsius this year, right from the whole power grid system in US is about to collapse because of the climate change, because of the heat wave that is generating, that is over there, and because of the scorching heat over the Siberia and Europe, which makes it a record low ice coverage in the Arctic Ocean's Laptev Sea for the first time in the history of human civilization, or I would say like for the last after the last ice age. So what we need to do, how we can get rid of this global warming phenomenon? There are different strategies, there are different policies that policymakers are and also scientists and researchers are actually working on, and they want to find out and different the type of technology, the type of strategy which have a maximum impact and which can give us the maximum impact in a very short point of time, because we already exceed the I would say that it's called the time of we cannot return to the same pre-industrial level of global situations which now we are running on. So one of these technologies are the carbon capture, because carbon dioxide, as we know, carbon dioxide, it captures the infrared wavelength in radiation from the solar as well as the outer celestial bodies, and it because of it is absorbing this infrared radiations, and because of that it can absorb the heat, and it is there in this atmosphere for different anthropogenic activity, and it increases the temperature of the earth in general, especially in the lower stratosphere level, and because of the overall temperature of the earth is becoming higher and higher with the time. So what are the sources of this carbon dioxide that is being generated due to the anthropogenic activities? The major sources are obviously the power stations. The power stations which are run by the fossil fuels, coal, natural gas, crude oil. No, even if you ask me, there are a lot of hoax going on. I will not say hoax. It's a lot of informative strategies people are making on the usefulness of bioenergy using different biomasses. So in general we say that the bioenergy is a very renewable form of energy sources. We can use it, obviously we can use it, but there are detrimental reasons, there are disadvantages of it as well. So I'll discuss on it later on in my later slides in details. So this graph I want to share with you, because it's very important for us to know the geographical relationship between the source and the storage storage opportunity. What do you mean? What do I mean by the storage opportunity? Because the carbon dioxide that has been generated by due to the anthropogenic activities can be stored in different means, and there are available scientific explanations out of it, and that I will show you in later slides. And how it depends on different region in our globe. As you can see, the left side of the y-axis, the coordinate axis, is showing the rank of the region, and the whole Earth has been like kind of, we are bifurcating, separating it in 11 different zones. And as you can see, USA being a very consistent, and it's really ranked in the first position in terms of total carbon dioxide emission, and their total carbon dioxide emission is nearly equivalent to the all the 9 least members of this of the least rankers of this x-axis, you can see. So which is really staggeringly high, more than 25%. Even China and most of the part of the Europe is actually generating huge amount of carbon dioxide, which is like more than 75% of the total. And it's really people should really think about it, because they are the the developed countries, and because they are the reason for most of the global warming gases and most of the detrimental gases that is being released by their industries and all. And anyway, so our Indian subcontinent condition is like and not so good, not so bad, I would say, because it stands around 6th position out of this regional ranking, and in terms of the carbon dioxide emission. But it has a possibility to use the store the carbon dioxide as well, because of its peninsular region, where there are a lot of sea coverages, and that in that sea we can definitely use the carbon, we can definitely dump the carbon dioxide. Well, it sounds very ridiculous how we can dump the carbon dioxide in the sea. I'll tell you, and it's actually happening for the last 25 to 26 years. So now we know the sources of carbon dioxide. So how to capture it? There are different capturing mechanisms that has been introduced by the scientists. So one of the most followed mechanism is post combustion. What do we mean? What do I mean by the post combustion? After the fuels, if it might be renewable or non-renewable energy sources, when it is combusted and use it for the power and heat generation, then the flue gases which is generated out of this combustion procedure is used by different I would say it's called there are dog houses in the it's called dog houses in the air in the for separating the obnoxious gases from the flue gases. It's called dog houses, and there are also electrostatic precipitator and all this. There are different mechanisms how to get rid of this different obnoxious gases, and also the global warming gases from the flue gas, which is generating out of combustion of the fuels. So this is called post combustion process, and with this process we can separate the carbon dioxide. We can use different kind of adsorbent, carbon dioxide adsorbent, like monoethylenamine and all these kinds of. We can adsorb it in that liquid, and then we can easily separate this liquid again and regenerate the carbon dioxide upon heating, and we can get almost very pure carbon dioxide. And that pure carbon dioxide, with proper pressure, if we can provide proper pressure, it will be liquidified, and it can be stored, and it can be transported. So this is the fundamentals of the post combustion procedure of carbon dioxide capture. What is pre-combustion? In case of pre-combustion, what it does, instead of going for the combustion of the fuels, before that only there is a procedure called the fuel gasification. So using this gasification technique, before using it for power and heat generation, it used to give us the carbon dioxide and the other gases separately. So once we get this carbon dioxide separately before even power and heat supply applications, we can use this carbon dioxide as a pure form. And one of the main advantages of pre-combustion is that in this case, carbon dioxide is already at its higher pressure range. Because of high pressure, it is already liquidified, or upon providing a little bit of pressure, or upon providing pressure, we can make it liquidify very easily. So which makes the amount of transporting area volume less, and because of that it is much more comfortable, and which has been used in different industries nowadays. Another technique is called oxy-fuel. What do you mean by the oxy-fuel? As we know, when we use the fuel and when we burn the fuel, we use the air, In air, almost more than two-thirds of its more than 77 to 78 78% of it contains nitrogen, and only 21% or 20.9, or to be precise, like it's oxygen. Because of the presence of nitrogen, when it hits the fuels, it develops different other kind of flue gases. But if we use only pure oxygen instead of air, if we only use pure oxygen to heat this fuel, to heat this different kind of fuel sources, we can get pure carbon dioxide and H2O. Upon using proper precipitation, proper separating techniques, we can get proper carbon dioxide. So, and also different industrial processes are also there where we use it. There are different kind of industrial processes where people use pure air or pure oxygen to get the carbon dioxide out of the industrial processes. So these are the procedure to capture the carbon dioxide. So now we know this, what are the sources of carbon dioxide. We know the capturing techniques that we can follow, and this is two of the examples of almost 3.3 megaton of carbon dioxide per year of capturing capacity of cold gasification unit is there at North Dakota. And even when they use this carbon dioxide, which is captured using this which using this plant, they use it for enhanced oil recovery. What is enhanced oil recovery? I'll tell you later in the later slides. So, and also there is in the right hand side, you can see another carbon dioxide capture plant in Malaysia with around 200 ton per day of capacity. So now we know we have already captured the carbon dioxide. Now we need to transport it, or to store it somewhere, to give it to some places where it can be it can be well utilized. So the third thing that we need to discuss about how to transport this carbon dioxide. It's not an easy deal. According to the Canyon Reef Carriers Delivery Meter, it's a very standard procedure that people have used in this industries. So according to that, at least 95% in mole percentage carbon dioxide has to be there in the product. Then only it can be delivered properly. What do I mean by delivered properly? Either by using the big tankers or by using the simple pipe. Up to 1,000 kilometers of people, we can usually use the pipe, but beyond that, it is not feasible enough. So then we can use different type of moving vehicles. Most of the cases we use the tankers. It shouldn't contain any free water. It shouldn't contain more than 15 ppm of H2S. It shouldn't be more than around 50 degrees Celsius of temperature. And these are the different criteria when the specimen carbon dioxide liquid should have, so that it can be transported easily. So now one very I would say, like a very important thing that I can share it with you, like as you know, at different depth of ocean or any liquid medium or any fluid medium, at different depth we have different pressure level, right? So upon providing because of the different pressure, the air that is there, like in the carbon dioxide, which is in the gaseous form, it can be converted into the liquid form because of the pressure, that is inherent pressure that it is experiencing. So because of that, if we can store the carbon dioxide at least 2.5 kilometer below the surface of the water level, sea surface, then we can have at least 2.7 only, instead of 100 gram per I would say instead of you can see the density becomes like from 100 to it's 2.7 only, which is like almost, I would say, like almost 30 to 40, more than 30% is 30 times decrease in volume can be obtained using this kind of technique. So this is the fundamentals why people go for this ocean storage of carbon dioxide that I'll be discussing soon. So you might be thinking like how it is possible to store carbon dioxide, like there might be some huge amount of pipelines that is needed. It's unnecessary, whether it is feasible or cost effectiveness and all these things. Definitely we believe me, scientists have already discussed about it, and they have already worked on it, and there are a lot of literatures available on that, and there are almost standard mature technologies being developed on this matter as well. In the right side of the right side of the slide, you can see a small graph, the table about the capacity and the length of the pipeline that has been used. The Cortez, the one USA company, at 1984, they have developed 808 kilometer long carbon dioxide pipelines to store it in the middle of the ocean, not middle of the ocean, in the deep inside the ocean. Okay, so now we know that transport is carbon dioxide is also possible. So what are the possible storage vessel or storage places are there for this carbon dioxide? As you can see, the location of this is the this is the location of our Earth, like this is our globe, and you can see the star marks, and the red square, which is filled red square, is actually showing the storage capacity which is already in action at different part of the world. And this red square with not filled one is actually showing the one which is actually proposed and it is underway. In India, there is no such proposal as of now, but there are work going on in ISC Bangalore, so Indian Institute of Science Bangalore, and there are certain development programs going on by the Central Pollution Control Board, New Delhi. So in future, I would say in future, it is all there will be there is a chance of having a very big carbon dioxide storage plant in the southern part of the India. So what are the options for storing the carbon dioxide? As you can see in this picture, it is mentioned 6 different storage criteria. So first, as you can see, this is the deep unused saline water saturated reservoir rocks, where we can directly just push the carbon dioxide which is stored and transported from the industry or from its due to different anthropogenic activity. We took it and we just store it in the deep unused saline water unsaturated reservoirs. We can use it for enhanced oil recovery. So what is enhanced oil recovery? As I have mentioned earlier also, we push air. Earlier days, like even 30 years back also, we push air. Most of the times we try to get rid of the oxygen because there's a high chance of getting burned because of the oxygen environment. We try to get rid of the oxygen, but it is not always possible. So we put air, and by using the pressure in the aquifer, we get the oil back from the system, or the aquifer, or the oil reservoirs present over there. It's not called aquifer, it's like aquifer for like oil, so oil reservoirs. So these oil reservoirs, we can easily get the oil out of it. So why not we use the carbon dioxide instead of using the air? So that's what it's going on in almost 33 different plants, and 33 different plants in the world now. People are working on it. They just put the carbon dioxide just directly through the pipeline to the system, and from the other side of this, because of the high pressure that is being generated in the oil reservoir, the oil is coming out. It's a feasible process. We can get the carbon dioxide dumped on the mine. We can get the oil out of the system, so which is kind of feasible. There are different advantages, disadvantages as well, which I'm not going to discuss at this moment because it will take a lot of time. Then there are depleted oil and gas reservoirs which are not in use. We can just directly put the carbon dioxide. We can have a pipeline and we just store it over there. We can store it using the deep unminable coal seams. Most of the which is that there is a coal available there, but it is unminable. You can directly put the carbon dioxide there, and which will make it easier for the carbon dioxide to form in different other forms. And because it's already the environment is already there, because the coal is already there, so it will be easier for coal. Okay, there are certain parameters as well which will make a important role here, but still if we can put the carbon dioxide, store the carbon dioxide in this kind of coal mines is also possible. Another procedure is a lot of cases we can get rid of the methanes present in the coal bed. We can get rid of the methane present in the coal bed, which is considered as one of the main reason of a lot of accidents and all inside the coal mines and all. So we can just directly push the carbon dioxide in those coal mines, and we can take the methane out. As we know, methane has a very high heat capacities and all, which we can use as its calorific value is very higher. It's higher than the higher, and we can use it as a biogas, as you have already know. Other than hydrogen, the second most useful gaseous biogas is the methane, CH4. So that we can use for different other purposes. So it's kind of win-win situation for us. And there are different other procedures as well. We can just directly put the gas in the basalt region or the wild shale region, where the basalts which actually get weathered. Hello, am I audible?
Yeah, you are audible.
Yeah, okay, sorry. Yeah. So these are the different storage options that we have discussed. So there must be some questions came into your come into your mind that how it's possible, like how this carbon dioxide storage has been taking place in the deep down in the soil or deep down in the water bodies or in the mines or in the basalt regions. Or so there is a simulation of study by Kumar et al. 2005. After Kumar et al. 2005, it says that it shows that after 50 years of injection of carbon dioxide into a base of a saline formation, we can get, even after 50 years also, the most of the carbon dioxide is still mobile and driven upwards by buoyancy force, and through the capillary action it goes up time to time. If it's a only if it's a land region, if it's a land region or the basalt or any land formation. So if it is a saline formation, if it's a water body, then only because of the buoyancy force it driven upwards, very, not a very drastic way, but very slowly. And after 1,000 years, the simulation, though it is not done in a real film situation, real case scenario, it is done in a simulation software, and it is said that after 1,000 years, even the buoyancy driven flow has expanded the volume affected by the carbon dioxide in not much, and also it trapped the residual carbon dioxide saturation and or the dissolved in brine in such a way that it won't go further. So only a little bit of carbon dioxide is mobile phase, and all the other carbon dioxide are contained well within the aquifer. So it is possible, according to the simulation results and according to the existing reports done with the existing plants that is running on this carbon dioxide storage phenomena. They said it is possible, and it is not only possible, it is very, very much possible. So with the time, in the right hand graph, in the right side figure, you can see the increasing storage security with the time, the trapping contribution. So the trapping contribution is increased with the time, as you know for sure, because the carbon dioxide, if there is a aqueous environment there, so it becomes either in carbonic acids, and the carbonic acid it reduced down to the different kind of carbonates, and these carbonates are actually the reason which can work with different minerals present over there. They can work with the minerals, they can react with the minerals, and as you know, the minerals means, I mean, like different kind of calcium or magnesium minerals, silicate minerals as well. They act with this kind of carbonates, and they make the very stable form of they trap the carbon dioxide in their stable mineral forming mechanism. So now the mineral that was there in the carbon dioxide that we have introduced as a gaseous form, it becomes solidify, and it becomes a solid material there now. So once it is become solid material there, it is we can consider it as a trap. It is trapped for at least 10,000 years for the till we take it out and we use it for other purposes and all. So this is the way of geochemical trapping or physical trapping that we use for carbon dioxide sequestrations. This is one elaborated figure about how the carbon dioxide injection well help to get the enhanced oil recovery using from the oil reservoir. The carbon dioxide has been injected, and it obviously drives the oil to using the production well, we can get the oil out of it. And obviously with oil also we'll get some natural oil also. There must be some adsorbed carbon dioxide present with it, which has to be recycled, which has to be regenerate using different techniques are there, which is very easy to regenerate this carbon dioxide, and then we can use it and recycle it back to the carbon dioxide oil. And this is a practical and so on. This carbon dioxide, this typical carbon dioxide field operation setup is there in Wave 1 surface facilities in Canada. Okay, so now we talked about the different carbon dioxide storage capacities mostly in the geological formations. Now, how oxygen storage takes place. Oh, it's a huge thing, right? So as you can see, the carbon dioxide has been transferred from, which is like already captured and compressed in a pipeline. It is transferred through different zones of sea level, different stairs of sea levels, I would say, and we make depends on the size of the pipe length and at which point we are actually depositing the carbon dioxide. There can be different phenomena that is releasing that can be happen in the vicinity of the region where we were actually depositing the carbon dioxide. So I'm not going details into it. So these are the possible scenario. What we can do, we can directly push the carbon dioxide in the carbon dioxide lake. We call it lake because it's a liquid carbon dioxide and is very well below the surface of the seawater level. And as you can see, it is the 3 kilometers. So it is well below 3 kilometers. Yeah, so this is the way we can store the carbon dioxide using the oceans. There is another procedure, we call it mineral carbonization. As I have already talked about it a little bit, that how mineral carbonization has taken place using different kind of silicate based rocks, mostly basalts and all. So how do they work? They work with the carbon dioxide, that they make calcium or magnesium carbonates, and these calcium magnesium carbonates are in solid form. So now once it is in this form, we can use it. We can not only use it for storing purposes or disposal, but also we can reuse in different construction purposes as well. This minerals, we can use it for construction of road. We can use it as a cement. There are industries, there are scientific exploration that has been happening for people for using the carbon dioxide trapped from the air, and they can use it for making a brick or cement for the construction material. Just imagine, it's a huge discovery, and people are working on it, and they're maybe within 10 to 15 years we'll be having our home constructed with the material using this carbon dioxide sequestrated bricks or sequestrated cement material. What are the other carbon capture technologies other than this very geological ones? There is a provision to capture carbon by using the microalgae. So I have a kind of a double-hearted feeling telling about it, because when you use the microalgae, but when you use it and because most of the cases, if you're not being able to produce the biodiesel or any kind of biofuel out of it, and you just let it dry and decompose, in that case the carbon dioxide that has been captured is not properly being used. In that, we say microalgae has a very high carbon dioxide capture capacity, atmospheric carbon dioxide capture capacity than the land, most of the land plants. But it can only be well utilized when it is formed to when the lipid has been extracted from this algae, and we can use the biofuels out of it. Otherwise, if it is not utilized in such a way, then there's no way of I would say there is no pros part of this microalgae utilization for carbon dioxide capture. There is another very interesting topic that is going on, that is being under research by different labs all over the world, that is called ocean fertilization. So what is ocean fertilization? There is another funny name, not funny name, it's called iron, I forget, it's like it's kind of iron synthesis or something like that. I forget the iron addition. Sorry, it's called only iron addition. I forget the exact term. It's like iron addition, something like that. So how does it work actually? When you add any iron-based mineral in the sea, there is a generation of phytoplankton. Phytoplankton generation, it's called phytoplankton blooming. So when the phytoplankton blooming will happen, so phytoplankton has a very high tendency to capture atmospheric carbon dioxide than any other plants in the world. Okay, some microalgae are superior to them as well, but these phytoplanktons can capture the atmospheric carbon dioxide, and they can go deep into the ocean, and this is the way how we can store huge amount of carbon dioxide in the very bottom of the sea, as a our carbon dioxide storage device. So though it is not in a feasible marketing strategy as of now, because of different cons part of it, people are working on it, researchers are working on it, maybe we'll see some fruitful output out of it as well. So there must be one concern that is going on in our head, like what is the cost related to it? Why we are talking about so much of carbon dioxide relocation from one place to another? Why not we have just collect the carbon dioxide from the atmosphere and we can just use it for some feasible purpose? Frankly speaking, there is no good device, or I would say like yet to be discovered, which directly capture the carbon dioxide from the atmosphere and we make it some useful form. Because as we know, carbon dioxide is very less in atmosphere, and 0.03% or so, which is very less, and there is no current fruitful devices. There are devices, and there is no fruitful or which devices which can capture the carbon dioxide in a carbon positive way. What do you mean by carbon positive way? Capturing the carbon dioxide needs some, instrument to run and all these things. So for running that instrument, it needs some carbon. It needs some carbon as well. What do you mean by carbon? I mean like the electricity and all these things. So in general, we need to develop something which will give us some carbon positive value, not the carbon negative. So that's why it is not possible, and that's why we talk about so complicated stuffs, how to use the carbon dioxide, how we can capture the carbon dioxide and we can use it. It was complicated 10 years back, but it is not. Believe me, within a couple of years it will be very feasible industrial level solutions, and people will be using all over the world very finely. And yes, the cost estimation, as you can see, the ocean storage is cost only 5 to 30 US dollar per ton of carbon dioxide injected. Okay, at this moment of time we don't bother about ton of carbon dioxide, but in after 50 years it will matter. It will be really a concern for us, believe me. So as I have discussed different carbon capture and storage devices, what are the technologies which is already there in a mature market, which can be used? And I want you all to know about these things which is going on all over the world, because I think it's a very new thing, and this everyone should know and everyone should work on it in future. So because in India there are very few labs which are working on this kind of technologies, we should work on it and we should develop some technology out of it so that it will be very much beneficial for our future generation. So in general, the industrial separation techniques, the enhanced oil recovery, as I have mentioned, and there are some other industrial uses of carbon dioxide which is reaching the mature market stage. I think I shouldn't go through what is the difference between the research phase, demonstration phase, economically feasible under specific condition, and mature market. Mature market means the technology has already been matured. It is considered as it is technological readiness level is already more than +6. So when it is more than technology readiness level is +6, means you can utilize it, you can well utilize it in your home purpose. If it is for your home, you can use it for industry purpose if it is for industry, and so on and so forth. So yeah, so that's it from my side. Thank you so much. I'd really love to answer some few questions.
Yeah, we will move on to our interactive session. Participants, you may ask directly to my speaker if you have any question.
Hello, sir. Thank you for the lovely talk.
Thank you so much.
I just wanted to know that you mentioned about a carbon capture project in India, and I had read an article in Nature Communications that there is a project ongoing in UC San Diego about a wartime level investment in direct air capture in the carbon sequestration industry. That is carbon sequestration directly into the ground. So, is the Indian project related to that? Means, yeah.
Well, I do not have exact idea about the Indian project, what is it about, exact details about the carbon sequestration technique that they are following or that they are researching on. So I cannot say at this moment exactly what they are doing, but I know they are working on this carbon sequestration techniques. Okay, a different kind of carbon sequestration technique has been followed in IIT Kharagpur as well, even in different institutes in different institutes in India. It's not only IISc Bangalore, but by means of IISc Bangalore, I mean to say it. But specifically some major project like in IIT Kharagpur, we are also working on carbon capture technologies using the microbial carbon capture cells. So how it works, we use microbial carbon capture cell, we use algae to capture the carbon, and then we use this algae to produce the biofuels, different kind of biofuels. So that is also going on in India as well, but it's in small scale. In IISc Bangalore and Central Pollution Control, they are working in a very large scale model. I do not have exact idea about it. I'm sorry. Hello.
Please check once the chat box. There is a question from Urpita Mojumdar, I think.
Okay. It's actually there are pros and cons. Definitely, you're absolutely right, because first pros and cons is like you have to. Okay, if you don't mind, I can. It's a very nice question. I would really like to share you one slide which I hide it because of the time and all. You see, can you see this slide? Hello?
No, sir.
Okay, can you see the slide now? Hello?
Yeah, yeah.
Yeah. As you have mentioned, it's really a nice question, and there is a chance even in 50 years, within 50 years of time, also it's still in mobile phase. So there are, and that is the reason there are different escape mechanism which has been already witnessed by the researchers. So as you can see from this nice figure, it is very well mentioned the different escape mechanisms for this carbon dioxide gas which you intended to put in the storage thingy where or the aquifer or the storage places, and you want it to be retained there. But there are different factors which are very much important. There is a chance of getting the carbon dioxide leaked through the ridges of the different geological formations. There is a chance of getting leaked by the carbon dioxide through the uncapped well which is there, because we need to really, when the well, any deep well, bore well, we after use, we need to cover it. If it is not, we are not using it, we need to cover it, or we need to somehow we need to cement at the bottom of the floor, bottom of the this kind of wells, which we do not do in general, which it is not performed in um, most of the places. So in that case, this carbon dioxide can, if it is near to any well, it can get leach through this kind of wells as well. There is a natural flow of water if the aquifer, it is connected to any aquifer where we put the carbon dioxide, and this aquifer is a source of natural spring for any hydrological system. So it will directly go through it, and it will dissolve in the water, and it will go to the surface, and it will somehow again get this carbon dioxide back to the atmosphere. So you're absolutely right, there is a lot of cons part. The pros parts I cannot say, because its pros part is like it's still there. Wait for a couple of more years, I mean couple means 100 or 1000 years. After then it will definitely become some different form, and when at that form it will be stored for long.
Thank you, sir. Thank you.
Well, okay, so hello.
Yes, sir.
Yeah, I saw another questions by Arijit. He is asking that for carbon dioxide storage in the ocean, it is solely on the ocean bed under the 3 kilometer mark, or is it a subsurface protocol? Okay, so it is not solely under the ocean bed, Arijit. It's you can do it at different stratum of ocean level, ocean water level as well. Well, it depends on what's your ultimate target. I mean, like if you can find there are some surface. Soil, or there is I mean like the bed soil, which is the sea bed soil. If it is rich in different kind of minerals, you can definitely put your oxygen, put your carbon dioxide over there, you can store it there. You expect that the minerals will definitely act with the carbon dioxide and will become in different mineral rocks, and it will be stored there for a longer amount of time. And if it is not, if you don't find that kind of scenario, that kind of provisions in the near to the ocean shores, seashore area, and the near less than 3 kilometer mark, then you have to dip it down further 3 kilometer. The positive thing about the less than 3 kilometer is that after 3 kilometer, the density of the carbon dioxide itself becomes very high, and because of that, it won't just because of the buoyancy force, it won't go much. Like it depends, it won't, I mean like it won't sink. It will be there for a longer period of time, and it will take the surface or the sea bottom will take more amount of time to get it absorbed to its surface by different other means. Welcome. Anything else?
Okay, so thanks a lot to both of my speakers for giving us their time and enlightening us with their words. I would like to request both of my speakers to fill out the response form that has been sent to you, as well as my guest to fill out the form that has been given in the chat box. And thank you all for joining my webinar. And I would like to conclude the session for now. Thanks a lot again for attending.
Thank you so much, Somasree.
Thank you.
Thank you. Thank
Thank
you.
you.
Thank you very much, Somasree and all, and Mr. Gourav.